In this video, we're going to find all the key features of a parabola where it opens up. So to find the roots of this parabola, which also known as the solutions, the x-intercepts, or the zeros, that's where the graph crosses the x-axis. So for our graph, it crosses at -1 and 5. So therefore, the solutions for this parabola is x equals to -1 and x equals to +5. And you can write those two solutions as a point as well, where x is -1, and for the solutions, y value is always 0. And the other one, your x is 5 and y value is 0. To find the y-intercept, that's where the graph crosses the y-axis. So we can see that our graph crosses at -5. So therefore, for the y-intercept of this point, your x value is always 0 for the y-intercept, and the y value is -5. The vertex of a parabola is either going to be the maximum or the minimum. Because our parabola opens up, it's going to have a minimum value. So find the minimum point of this parabola, which is right here, and you're going to go towards the x-axis to find the x value, and then go towards the y-axis to find the y value. So our vertex point is x value is +2 and y value is -9. And to find the axis of symmetry, that's the line that cuts this parabola in half. And as you can see, that axis symmetry goes right through the vertex. And because it goes right through the x value, which is 2, the equation for this axis symmetry is x equals to 2. And you should be aware that because the vertex and the axis symmetry, they meet, so therefore they always share the same x value. To find the domain of this graph, you want to read the graph from left to right. So the values that go left to right are your x values. So therefore, when you write the domain, you're writing the x values. So place your pencil vertically on the graph like this, and you can see that when you place your pencil vertically on the left side, it's going to start an arrow, which means that the graph is going to continue going towards left. So therefore, as I'm going towards left, my x values are getting smaller and smaller. So therefore, for my domain, it's going to start at -infinity because it never stops on the left side. And as you move your pencil towards the right, it ends on an arrow again. So that means that your domain doesn't stop. It's going to continue move towards the right, and your numbers are going to get bigger and bigger. So therefore, it ends as at a positive infinity. So when you have a domain from -infinity to positive infinity, you can also call that as all real numbers. To find the range, you want to start from bottom to top. So place your pencil horizontally and start at the lowest point of the graph. So because I'm going from bottom to top, I only want to write down the y values for the range. And the y value of this lowest point we said was -9. And because it's a closed circle, so I'm using a bracket. So it's going from -9, and then move your pencil up. And you will see that it ends on the arrows, so that means it's going to continue go up. It never stops, so therefore the range ends at positive infinity. And you can rewrite this answer as an inequality sign. So all your y values has to be above -9. So you can rewrite this answer as y is greater than or equal to -9. To find out whether the graph is increasing or decreasing, you're going to read it from left to right, just like the domain. So therefore, when you write the interval of increasing and decreasing, you're simply writing the domain. So place your pencil on the furthest left of the graph, and you'll see that it starts an arrow on the left side. So therefore, you know that the domain is going to start at -infinity. And as you trace this graph, the graph is going to go down first, and then it's going to go up. So therefore, I'm going to write my domain. Again, place your pencil vertically on the left side. And again, I started with an arrow, so therefore I have a negative infinity, decreasing, and then it stops decreasing at x value of 2. And then after the 2, my graph is going up, so it's increasing. And again, it's increasing, it stops at arrow again, so therefore it's going to be a positive infinity. So again, you can write increasing and decreasing as inequality. So for decreasing is all the numbers on the left side of the 2. So therefore you can rewrite this as x is less than 2. And then for increasing is all the domain is greater than 2. So you can say x is greater than 2. The graph is positive when it is above the x-axis, like here. And when you write the domain for the positive, again, you're reading it from left to right. So we are starting on the arrow side on the left side. So for the positive, we're starting with negative infinity. And then move your pencil to the right, and you will see that it stops at negative 1. And because the positive graphs are not connected, you're going to say union, and then again continue on the left side. It starts at 5, and it continues to right, ends at the positive infinity. And you can write your answer as an inequality. So for the first one is all the x values less than negative 1. So x is less than negative 1. Union means or, and then for the second one is all the x values bigger than 5. So x is greater than 5. And the part of the graph where it's negative is when the graph is below the x-axis, because again, for every single point on this graph, the y values are negative. So to write the domain, you start from left side, which is negative 1, and it ends at 5. So to write your answer as an inequality, your x has to be between negative 1 and 5. For the end behaviors of the graph, you're looking at the ends of the graph. So you want to know what happens to your y values when your x values get smaller or bigger. So to help you figure that out, I highly recommend you writing down the signs for each quadrant. So for the first arrow, it's in quadrant 1, where both x values are positive and y values are positive. And then the second one is in the second quadrant, where x values are negative and the y values are positive. So for the first one, as x values gets bigger and bigger, so that's positive infinity, the y values are also getting bigger and bigger because it's going up. So positive, positive is the same sign. And then for the second end behavior, as x goes to the negative infinity, y is going to positive infinity. And these are the end behaviors for this graph.